And we're back in better than ever in 10.3% composition and chemical formulas. We're currently trying to show you how to calculate a mass percent or a percent composition of the individual elements in a compound. And so for this next example, let's go ahead and use, say, sodium iodide, NaI. Now, at first glance, you might say, well, it's half sodium, half iodine. You have one sodium and one iodine. But again, we're talking about mass here. So let's go ahead and write this down. We have 1 mole of sodium, and we have, let's go with a purplish color here since iodine is a purple substance. We have 1 mole of iodine, I. Now we want to change that into grams because it is a mass percent, or when you're dealing with percent composition. So sodium weighs 23.0 grams per mole, which means that we have 23.0 grams of sodium in 1 mole of sodium iodide. With the iodine, the iodine has a mass of 127 grams per mole. So that gives us a mass of 127 grams of iodine. And so when you add that up, we have a molar mass that's going to be 150 grams total. Now to get the mass percent, you simply take the parts divided by the total, so it's 23 divided by 150 times 100%, and that's going to give us a mass percent of sodium of 15%. We'll do the same thing with the iodine. Take the 127 divided by 150 times 100, and the mass percent of iodine is going to be 85. And so what you're looking at is a compound that would look something like this. Now this is an ionic compound. So if the iodine, which would be iodide, looks like that, the sodium that's sticking to it is going to be quite a bit smaller. It's going to be more like this. Something like that. And then they're held together because one's positive and one's negative, and so they attract one another. Alright? But the percentage, anyways, 15% sodium and 85% iodine. Let's try one more. We're going to try iron 3 hydrogen phosphate, which has a formula of Fe2 HPO4 3. So it looks like there's quite a bit going on here, and really it's the exact same that we've been doing for the past few examples. So let's go ahead and try this. We have, let's start with red. In the compound we have 2 moles of iron, Fe. We have, switching over to say blue, it looks like we have 1 hydrogen, but there's a 3 over here, so we have to distribute that across the parentheses. 1 times 3 gives us 3 moles of hydrogen. We have, it appears 1 phosphorus, but the same thing, distribute the 3. We have 3 moles of phosphorus, P. And with the oxygen, we have 4 times the 3 that gets distributed. We have 12 moles of oxygen. And so that's the mole breakdown in 1 mole of compound. So let's go ahead and change those into grams. Iron has a molar mass of 55.85 grams per mole. And so we're going to have a total of 111.7 grams of iron in the compound. With the hydrogen, hydrogen has a molar mass of 1.008 grams per mole. So we have 3.024 grams of hydrogen. The phosphorus, we have a mass, or molar mass of 30.97 grams per mole, and that's going to give us a total mass of phosphorus anyway of 92.91 grams of P. And finally, with the oxygen, the molar mass is 16 times the 12 gives us a total of 192 grams of oxygen. So now, if we add those all up, the total mass of the compound is 399.6 grams per mole. So therefore, the percentages are simply going to be the individual parts all divided by 399.6 times 100%. Alright, so when you do that calculation, you should get a percentage of iron that is 28.0% iron. The hydrogen is a mere 0.8%. The phosphorus is 23.2%. And the oxygen is 48%. And if you add those all up, you do get 100% total, as you pretty much should. So that is how you calculate percent compositions. It is just calculating the individual masses of each element in the compound, dividing it by the total mass of the compound times 100%. In the next podcast, we're going to introduce you to the idea of empirical formulas and molecular formulas. We'll see you next time.